Welcome back to Machine Learning Techniques lecture. This is the fourth lecture on machine learning techniques, and the code for the subject is BCS 055. So my name is Vaishali Deshwal and currently I'm working at AKGEC Ghaziabad. So today in this presentation we'll discuss decision tree learning, its representation and its foundational or one of the core algorithm, that is ID3 algorithm, and some of the appropriate problems for decision tree learning. So this is unit 3. We have already covered unit 1 and unit 2 in the previous videos. You can check that. So let's start with the definition of decision tree learning. So as a name suggests itself, it's a tree. So it comes under supervised machine learning algorithm, where data is continuously divided at each row. So it's a tree-like structure and data is divided at each row based on certain criteria or certain set of rules until the final outcome is generated. It's a method for approximating discrete valued target functions. Discrete, we have two types of target functions. One is the continuous one, the other one is discrete. Discrete refers to the classification. The categories can be 0, 1 or yes or no, true or false, like that. So in which the learned function is represented by a decision tree, and learned tree can be represented as a set of if then rules. So ultimately the goal is to derive some if and then rules, the set of if and then rules, to improve the understanding or the human readability, because to understand the rule, it's quite intuitive for the human beings. Now, these learning methods, they are among the most popular of inductive inference algorithms. So we have a term called inductive inference algorithms, and there are so many algorithms in under this head. One of the algorithm is decision tree. So it's an iterative and inductive. Inductive means we are inducing something. Machine learning algorithm, which is used for generating a set of classification rules. And in the end, we are getting some if-then rules. For a set of examples, producing rules at each iterations and appending to the set of rules. Now, they have been successfully applied to the various areas, from learning to diagnose the medical cases to learning to assess the credit risk of the loan applicants. So it's a many application, and basically we use decision tree for the classification purpose, and it comes under supervised learning. Okay, now how to represent it? So this is how we will represent the decision tree, and these are the rules. Here we are using some conjunctions and disjunctions for the representation purpose. So let's see it. Decision tree representation, or we can say we use this particular algorithm for the classification purpose. It classifies the instances by sorting them down the tree from the roots to leaf nodes. And we all know that what is root and what are some leaf nodes. So which provides the classification of the instances. In the tree representation, we have nodes. They specify the test of some attributes. So we have some attributes, and each node represents the test of some attributes, and each branch descending from that particular node, suppose this is a node, and each branch descending from it, it is correspond to one of the possible value for that attribute. For example, see this figure number 3.1, we have outlook, humidity and wind. So if outlook is sunny, then we check that whether it is a humid condition or not, whether humidity is high or normal. If it is high, then we are getting a no, and if it is yes, then if it is normal, if the humidity is normal, then we are getting a yes. So here the decision tree for the concept play tennis. So here we have a concept called play tennis, and we are going to learn it, that whether a person will play tennis on a particular day or not. We are going to classify that person, that whether he will play or not. So it's a classification problem, and the concept is play tennis. We need to learn this. That is why we are saying that it's a concept. So an example is classified by sorting it through the tree to the appropriate leaf node, returning to the classification, and ultimately in this classification we have two classes. One is yes, the other one is no. Yes means whether the person will play tennis, and no is that the person will not play. So it classifies the Saturday morning according to whether or not that are suitable for playing tennis. So if it is outlook, if the outlook is sunny, or the outlook can be overcast, or the outlook can be rain. So we are testing that whether if the outlook is sunny and humidity is high, then the person will not play. If outlook is sunny and humidity is normal, then he will play. So this is how we read it. Now in general, decision tree represents a disjunction of conjunctions of constraints on the attribute values of the instances. Means we are using and or for the representation purpose. As you can see here, we are using this and operator and or operator in this. Now each path from the tree root to the leaf node corresponds to the conjunction of the attribute tests, and the tree itself to the disjunction of these attributes. For example, we have just seen this particular figure 3.1, and now this particular figure, it corresponds to this expression. So here we are considering only the yes categories, this and this category. So we write like outlook is equal to sunny and humidity is equal to normal. We are applying and here because we are getting yes only after checking the humidity. If the humidity is normal, then we are saying that it is perfectly fine for a person to play tennis. So if the outlook is sunny and humidity is normal, then we are getting yes. Or if outlook is overcast, then we are getting yes. Or if the outlook is rain and wind is equal to weak, then again we are getting a yes. So in this expression, we write outlook is equal to overcast, or the other condition for the yes category can be if outlook is equal to rain and wind is equal to weak. Okay. Now the next topic is, so till now we have seen what is decision tree learning. It's a classification. Its algorithm comes under supervised machine learning algorithm, and it is used for the classification purpose. We have seen that how to represent it with the help of and no operators. So here we have the next topic, that is the appropriate problems for decision tree learning. Now decision tree learning is generally best suited to problems with the following characteristics. And what are those characteristics? The characteristics are these. If the instances are represented by attribute value pairs, means as in the previous slide we have discussed, if we have an attribute called outlook, so its value can be sunny or its value can be overcast. So where the instances are represented by attribute value pairs. For example, we have this attribute temperature. It has its value like hot and cold. Next is target function has discrete output values. Discrete means we have categories like 0, 1, true, false, spam or not spam. So we have, when we have the discrete output values, we can use it. Third is disjunctive description may be required. So we have seen this description, the representation. Fourth, the training data may contain error, because the decision tree learnings, they are quite robust to the errors, and that is why we are saying we can employ those algorithms in case when the training data have error. Then we have training data may contain missing attribute values. So if it may contain the missing values, the scenarios in which we have the missing attributes, there also we can apply decision tree methods, because they're quite they're easy, or we can say decision tree algorithms can easily solve those problems. Like it can be used even when some training examples has unknown values. For example, if the humidity of the day is known for only some of the training examples, so the data, when it has some error or we have some missing values, so there we can employ decision tree algorithms. Now, the most important part of this unit is the ID3 algorithm. And first, we will understand what is an ID3 algorithm, and then I'll do a numerical on it in order to understand that how this ID3 algorithm actually works. So first understand what is this ID3 algorithm is. ID3 stands for iterative dichotomizer 3. So, and it is named such because it iteratively, repeatedly divides the features into the 2 or more groups at each steps. Suppose we are having a root node and further nodes we have. So at each row, data is divided on the basis of some criteria. And that is why we are saying that ID3 repeatedly divides the features into 2 or more groups at each step. Now, it was invented by Rose Cullen. ID3 uses this top to down greedy approach. Greedy means at a particular moment, it chooses the best step which it can take. So here, in the simple word, the top down approach means that we start from building the tree from this top, or you can say this root node, to bottom. That is why we are saying it's a top to down approach. And greedy means that each iteration, at that particular iteration, the algorithm selects the best feature at that present moment to create a particular node. Now, the ID3 algorithm selects the best feature on the basis of some parameters. So, at each step while building a decision tree, it uses the information gain or just gain to find the best feature. So, it's quite important here to understand this term, what is gain or what is information gain. And the other important term is entropy. So, entropy can be defined as a measure of disorder or in the data set, or you can say in the target feature of the data set. For example, in the case of binary classification, where the target column has only 2 classes, yes, suppose, or no, suppose we have 2 classes here, so that's a binary classification. So in such type of classification, entropy is 0 if all the values in the target column are similar, or we can say homogeneous. So if there is no uncertainty, then it will be 0, and it will be 1 if we have equal number for both the values. Like if you have some yes entries and some no entries, then the entropy will be 1. The number of occurrence of yes and no are same. Suppose it is occurring 5 times, it is occurring 5 times. So the entropy will be 1. But when in all the columns, in all the 10 rows, for all the 10 rows, we have an entry called yes, then the entropy will be 0 because there is no uncertainty as such. So this is how we define it. So we have a formula to calculate the entropy. We denote our data set as S, and entropy is calculated as, this is the entropy of S. S is the data set minus summation pi into log base to pi. I is from 1 to n. Means we need to calculate this thing for all the classes. So n is the total number of the classes. If you have 2 classes, then we have to repeat the same formula twice in the target column. Now pi is the probability of the class I, or you can say the ratio of the number of rows with the class I in the target column. Okay. Now the next important parameter or the criteria on the basis of which a decision tree works is the information gain. Information gain calculates the reduction in entropy, and we are going to use this entropy feature in the calculation of gain. So it calculates the reduction in the entropy. It measures how well a given feature separates or classifies the target classes. The feature with the highest information gain is selected as the best one. So in the end, the feature with the highest information gain is selected as the best one or as your answer. Now the information gain for a feature column A is calculated as, suppose this is the column A for which you are calculating the gain, and S is the data set and you are calculating gain of this. Entropy of S, so we have already seen how to calculate the entropy. minus summation V belongs to values A. V is the value and SV divided by S, entropy of SV. So what is this SV? SV is the number of, or you can say set of rows in S. S is the data set for which the feature column A has the value V, and this SV is the number of rows in SV, and likewise the S is the number of rows in S. So we will see all these things or calculations with the help of an example. So this is an example to illustrate the operation of ID3 and especially of the entropy and the information gain. Consider the learning task represented by the training example. This is the training example for the target concept play tennis. So we want to learn that whether a person will play on a particular day or not, and that is why it's a concept that is called play tennis. It can be yes, it can be no. So it's a binary classification. We have two classes, yes or no. So here the target attribute play tennis, which can have two values, yes or no, and we have to predict that whether a person will play or not on the basis of these conditions of weather, that if the outlook is sunny or temperature is hot and humidity is high or wind is weak, then on these conditions or on the day one, whether the person will play or not. So ID3 determine the information gain for each candidate attribute, and here in this example we have 4 attributes: outlook, temperature, humidity and wind. Okay. And then selects the one with the highest information gain. So out of all these 4, we need to calculate the one with the highest information gain. So to illustrate this, we have a data set and we just name that data set S. S is the collection of 14 examples. As you can see here, we have 14 rows. So 14 examples we have in this, and of some Boolean concept. Boolean means it has yes value or no value, including 9 positive and 5 negative examples. You can calculate this. We have 9 positive, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 examples of yes, and we have 1, 2, 3, 4, 5 and 5 negative examples. So this is how this notation we can use to represent 9 positive and 5 negative to summarize the sample of data. Simply we will apply the formula of entropy. The entropy formula is this: minus summation pi into log base to pi. So entropy n plus 5 minus is equal to, first you need to calculate for the positive one, that is 9 is the one where we are getting yes value, divided by the total number. So total data set is 4, 14, log base to 9 by 14. It is for the negative one. Since it's a Boolean classification, so we have these two things only, and after calculation we got a value that is 0.940. Now here we need to calculate these things for each attribute, for each candidate attribute. So let's start with the first one, that is the outlook. So when the outlook is attribute is outlook, we need to find out that what are the values which can be taken for the outlook. So it can have sunny or overcast or rain as a values. Overcast can be sunny, or outlook can be overcast or sunny or rain. Now we need to calculate S9 positive and 5 minus. So this we have already calculated, 0.94. Similarly, we need to calculate the entropy for each value, that is sunny, overcast and rain. Now if you see a sunny example, in case of sunny, this how many times it is occurring? 1, 2, 3, 4 and 5. So 5 times we have sunny, and correspondingly we have sunny as no, then no, then no, and then yes, and then yes. So 2 times yes and 3 times negative. So here we write 2 plus 3 minus, and in the similar fashion we will calculate the entropy. Similarly, we will calculate the entropy for the overcast and for the rain, and then we will apply the gain formula. So here the attribute is outlook, that is why we place outlook in the place of A. So gain S outlook is equal to entropy S minus summation V belongs to, so here in this formula V belongs to values of A. So outlook values will be like sunny, overcast and rain. So it can have sunny, overcast and rain. SV by S, entropy of SV. Now entropy of S is 0.94. This is, we have already calculated, 0.94 minus 5 by 14. 5 by 14 means 5 is for sunny and 14 is the total number. So this is the probability, or you can say probability, or we are just putting these values SV by S. So first we need to do this for the sunny, so that is why F 5 by 14 entropy, and then S of sunny minus, same we will do for the overcast. Overcast is 4, so 4 by 14, and again we have 5 by 14. Multiply by their entropies. So its entropy is 0.971. So we'll put 0.971, and here you will get 0, and here you will get 0.971. So here you will put 0.971. After calculation, your value will be 0.2464. Similarly, we'll calculate the gain for the attribute temperature, which is 0.0289. Then for the humidity, which is 0.1516, and for the wind, that is 0.040478. So information gain is precisely the measure used by ID3 to select the best attribute. And now you have to compare the gain. So the information gain for the outlook is high, 0.246. Out of these 4, we have the maximum gain for the outlook, and that is why we can say that we will choose outlook as our root node. So according to the information gain, the outlook attribute provides the best prediction of the target attribute, that is the play tennis. So play tennis is our concept which we are trying to learn over the training example. And out of the 4, first we need to decide that which particular attribute I should put on the top, or the root node we can say. So here, on the basis of the values, I select outlook because of its highest value, and then the branches are created below the root for each of the possible values. Its value can be sunny, it can be overcast, and it can be rain. So this is the one iteration. And then we have every example for which the outlook is equal to overcast is also a positive example of play tennis. Why we are saying this? Because as you can see here, if it is overcast, then you get yes. Again, if outlook is overcast, again you get yes. If outlook is overcast, again you get yes. So 4 times overcast is occurring, and all the times you are getting a yes. So you can say that if the outlook is overcast, then it will be a yes. Okay, so this will be a diagram. Outlook, if the value is sunny, then what will be the next attribute? If it is overcast, then we can directly say it's a yes. And if the outlook is rain, then what will be the next attribute? Okay, so we need to calculate, or we need to find out which attribute should come here. So again, we have to repeat the same things for the temperature, for the humidity, and for the wind. On the basis of that, we come up with these values, like gain for the temperature is 0.5, for the humidity is 0.9, for the wind it is 0.01. So the value, the gain for the humidity is 0.97, which is the highest. So we can say that the next attribute will be humidity. Then we'll calculate or find the next attribute for this particular position. So we'll do the same calculation, finding out the gain. For example, here I'm taking attribute as a temperature. Temperature can be mild, cool. We have 2 values here. So you need to calculate the entropy for it. So entropy of S is sunny. Okay, so this we have already calculated. Then Okay, we have hot, so there is no value such, so it is 0. Then we have mild. In mild we are getting a yes, so it is 2 positive and 1 minus. Similarly, 2 positive and 1 minus, will apply the entropy formula and we get 0.91. Then for cool is occurring twice and 1 is yes, 1 is no. So entropy for this is 1.0. Again, you will apply the gain formula. We have two values here, hot and mild, and we have cool also, but its value is, okay, its value is 2, its value is 3. And hot is 0. So all the three values will write, like this is for cold, this is for mild, and this is for cool. So after calculation, you get 0.0192. So in the similar fashion, we'll calculate the gain for this humidity. Here we have high, so S of high. Humidity can be high, humidity can be normal. So high, it's a yes and it's a no, so 1 plus 1 minus. For the normal is occurring thrice and we have 2 yes and 1 minus, so we have 2 positive and 1 minus. So we'll calculate this entropy, then we have gain formula. After the calculation, you get 0.019. For the wind also, you'll calculate the same thing, and after this the highest value will get for wind. So here this attribute will be wind, and if the wind is strong, then it will be no, and if it will be weak, then it will be a yes. Okay, so in this manner you need to prepare your decision tree. So this is it for today. In this lecture we have completed, or we have seen decision tree learning, then the appropriate problems where we can apply the decision tree learning, and ID3 algorithm, and a numerical on that. So in the next lecture, we'll discuss some more concept related to decision tree. Thank you.